If you've ever used a tool like ChatGPT, you know it feels a little bit like magic. But what's actually going on under the hood? Well, in this explainer, we're going to pull back that curtain on the core technology that kicked this whole revolution off, the Generative Pre-trained Transformer, or as you probably know it, GPT.
All right, take a look at this. It kind of looks like Shakespeare, right? You've got the dramatic format, the character names in all caps, that old school rhythm. But if you actually try to read it, it's complete nonsense. And here's the wild part. A person didn't write this. Nope. This was generated by a small AI model that was trained on Shakespeare's plays.
And that leads us right to the big question. How on earth does a machine go from just seeing a bunch of text to creating something that can copy the style of a literary genius, even if it doesn't really get the meaning yet? That's exactly what we're going to break down.
Okay, so let's dive in by, just understanding the name itself. We've all heard the acronym GPT 1,000 times, but what do those three letters actually stand for?
It stands for Generative Pre-trained Transformer. So let's unpack that. Generative is pretty simple. It means it creates or generates new content. Pre-trained is absolutely key. It means the model is first trained on a massive amount of general text to learn the patterns of language before it's ever asked to do a specific job. And finally, Transformer. That's the revolutionary AI architecture that makes this whole thing possible.
See, the original Transformer was built for translation. It had two parts, an encoder to read a sentence and a decoder to write out the translation. The brilliant idea behind GPT was to just simplify. They threw out the encoder and focused everything on the decoder, making it a pure, lean, text generation machine. But the architecture is only half the story. The way it's trained was just as revolutionary, and it all happens in two very distinct stages. First up, there's pre-training. Think of this like the model's general education. It reads a huge chunk of the internet, not for any specific purpose, but just to get really, really good at one thing, predicting the next word. After that, you get fine-tuning. This is like its specialized job training. The model takes all that general knowledge and applies it to a much smaller, specific set of data, like, say, customer service transcripts, or, in our earlier example, all of Shakespeare's plays. And this was a total game changer. Before GPT, you pretty much had to build an AI model from scratch for every single new task. This two-stage approach created a generalist model that could then become a specialist, which was just way more efficient and way more powerful.
So now that we know how it learns, let's pop the hood and see what is actually doing the learning. We're going to take a peek inside the architecture of that decoder block we mentioned.
The difference here is fundamental. The original transformer had to see the entire sentence all at once to translate it. A GPT model, on the other hand, is autoregressive. It's a fancy word, but all it means is that it only ever looks at the text that came before it to predict what comes next. So what's inside this block? Well, it's got a few key jobs. First, it has to convert words and their order into numbers the computer can actually work with. Then you get to the engine room, masks multi-head self-attention. It's a mouthful, I know, but just think of it as the mechanism that lets the model weigh the importance of all the previous words to figure out what's most likely to come next. The other parts are there to process all that information and keep the whole network stable.
So, what does that word masked mean? It's actually really simple. The model is forbidden from cheating. It's not allowed to look ahead. When it's trying to predict word number 5, it can only see words 1 through 4. It's like reading a mystery novel. You can't just skip to the end to see who did it. This forces the model to actually learn the real flow of language, one step at a time.
And here's the crucial part. A GPT model isn't just one of these blocks. It's a stack of them, sometimes dozens, even hundreds, layered on top of each other. Each layer builds on the one below it, which allows the model to learn incredibly complex patterns, from basic grammar at the bottom layers to abstract ideas and writing styles way up at the top.
So, with all that architecture in our heads, let's circle all the way back to our first example. How does all this complex machinery end up creating that weird Shakespeare-like text?
It all comes down to a surprisingly simple objective. Every single component, every layer, every calculation is all working for one single purpose: to correctly predict the very next word in a sequence. That's it.
So when the model sees a phrase like, "the king is," it doesn't just pick one word. It actually generates a list of probabilities for its entire vocabulary. As you can see here, it might think there's a 65% chance the next word is dead, a 20% chance it's coming, and so on. Then, it basically rolls a weighted die to pick which word to use. And we can control how it makes that choice. There's a setting called temperature.
that acts like a creativity dial. If you turn the temperature down low, the model gets very safe and predictable. It'll almost always pick the most obvious word. But if you crank the temperature up, it starts to take risks, picking less likely options, which leads to more creative, but sometimes less coherent writing.
And that brings us full circle. The little model that wrote our opening text had been fine-tuned on Shakespeare. Through just predicting the next word over and over again, it learned the style, the vocabulary, the format, the sentence structure. But because it was a very small model, it never quite figured out the deeper meaning. It mastered the style, but not the substance, which is exactly what we saw.
So let's just zoom out for a second. The invention of GPT wasn't just some small improvement. It fundamentally changed the direction of AI research and, really, our whole relationship with machine intelligence.
I think this quote from the source material just sums it up perfectly. AI models went from being specialized tools, like a calculator that does one thing, to becoming universal interfaces that we can interact with using the most natural tool any of us have: language. This shift kicked off a whole new era. The questions we're asking are no longer just about solving one specific task, but about how to guide and work with these powerful general-purpose AIs. And that leaves us with one final, fascinating question to think about. Now that AI is starting to master the very thing that holds all of human knowledge, language itself, what's it going to master next?